to fx. This is if we want to find this derivative. Here we just notice the integrand, this ft. We replace t by here, the upper limit x. So we have this is fx. And we should know, right, the indefinite integral fx dx. We learned in lecture, yes, in lecture 1, lecture 4. Remember, it's a family of functions of x, and here the definite integral, this ab fx dx. This is a number. This is a number. Provided the a and b are fixed, and if the upper limit in a definite integral is variable x, here this is x, then the definite integral is a function of x. Here this is x, and a function of the form is called an accumulation function. And by the first fundamental theorem of calculus, you can wait a moment and I use this example. And maybe you can calculate this one. This is from 0. This is from 0 to x. If there is sin t, this is dt. And we want to take a prime.
Tout de suite, il y a aucun souci, permettez-moi de vous mettre en attente. Je vous vois l'un de mes collègues au département parcellaire pour transférer l'appel au niveau de l'extranet. Merci.
Okay, please tell me this one is equal to, by the first fundamental theorem of calculus. This one is equal to. Anyone? No? You listening? Minus cosine x? No. It's not calculate the definite integral. It's just calculate the derivative of this definite integral. Here we have this is prime. Okay, this is prime. This family, this one is equal to. Use the first fundamental theorem of calculus. This one is equal to. No one knows it. Cosine t? No. You see here, by the first fundamental theorem, here this is equal to this means from a to x. This is ft dt. Here this is prime, right? This prime is equal to fx. This means we just replace t by x. We have the that is fx. So here we know a is 0. And this one, a here is 0, and ft is sin t. Yes, ft is sin t. 20, ft is 20. So this one is equal to fx is x, right? Is x. Okay, is x. Yes, is x, right? Is x. And I have another, this one. If this one is equal to, if this one, here, a x here. If this one is equal to, this is the square root of 1 minus t square. 1 minus t square over here is equal to, maybe it's equal to 2t dt. This prime is equal to, and we understand this integrand. The integrand is equal to the square root of 1 minus t square over 2t. It's from 2z plus a. No. This is from a x. This is the square root of 1 minus t square over 2t dt. It is prime. Yeah, the square root. Yes, right. We just replace t by x. Is the square root of 1 minus x squared over 2x, right? So this is the right answer. In big words, maybe tomorrow night, because I didn't have the today is very, I want to write big, right? I want to write. So it's a little convenient for me to use this, I don't know the Chinese, the English word, but Chinese is 数位板，我没有安装好数位板，所以说tonight, tomorrow night, I think it can work well. Okay. And now I hope you understand the first fundamental theorem of calculus. And comparison properties. I remember how to do this theorem B by geometry. This is fg are integrable on AB, and fx is less than or equal to gx for all x in AB. And then we have the left here. This is fx is less than or equal to gx. So we find this one. The definite integral from of fx from a to b is less than the definite integral of gx from a to b. Here, we can say the left here. This left, if we have the curve, have the equation is fx, and so we know from a to b, this definite integral is equal to the area of the region R1, and the right is R2. Say the area of region R2. And we can use the definition to operate, and I leave it for you to learn it after class. Okay. And then we have theorem C. Theorem C, remember, we also learned it. This boundedness property. This means we have fx. We find the biggest value is I, and the smallest is this I. Between m and m for x in AB. Then we have this definite integral is less than m times b minus a, and greater than m times b minus a. The picture in figure 6 helps us to understand the theorem. Note that m times b minus a here. This is the height is m and the base is b minus a. So m times this is m times b minus a is the area of a lower small rectangle. This rectangle, and b minus a is the area of the large rectangle. And when if fx this the height here, this is m, they have the same base b minus a, and the definite integral because y is fx is between m and so we have this definite integral is the area and the curve, right? And this curve and the curve. So this is the boundless property. And we also learned the definite integral is a linear operator, linearity of the definite integral. This is because we have learned dx, the differentiation, and indefinite integral, and this is sigma, linear operators, and we can add a b dx to the list. So this is the linearity of the definite integral. Suppose f and g are integrable on AB, and that k is a constant. So k times f and f plus g are integrable, and we have the first equality is this is the constant. Constant k times fx, we can write k in the front, and then times this definite integral, and also the first and the third, the second and the third, we have the plus and the minus. First plus is equal to first calculate definite integral and then plus. And example 1, example 2. Because beginning our class, we have explained the first fundamental theorem of calculus. So here, I think it's easy for you to understand example 1. This is find d dx, 1x t cube dt. Okay, it's prime. So we just this means a is 1. Here the upper limit is x. The integrand is t cube. So we have the derivative is x cube. This is x cube. Example 1 and questions. Example 1. And example 2. Although here we find the integrand is a complicated function. If we first calculate this definite integral, I think it's a challenge for everyone to calculate this definite integral. And if we remember the first fundamental theorem, we find it does need to calculate this definite integral. We just give let t be x. So it's x power 3 over 2 over the square root of x squared plus 17. So we can directly write the answer by the first fundamental theorem. Example 2. Because I remember last time some students have questions about example 1 and example 2. Now today, and questions? No. Okay, we continue. Now we will introduce the second important theorem. This is called the second fundamental theorem of calculus and the method of substitution. The first fundamental theorem of calculus given in the previous section gives the inverse relationship between definite integers and derivatives. Although it's not yet apparent, this relationship gives us a powerful tool for calculating definite integers. This tool is called the second fundamental theorem of calculus, and we will apply it much more often than the first fundamental theorem of calculus. Okay, so this means the second fundamental theorem of calculus is very useful for us to calculate the definite integral. Here, the theorem A. Let f be continuous. Continuous is integrable on AB, and let this is another function f. Another function f be any antiderivative of f on AB, because f has infinitely antiderivatives, and then we have this definite integral is equal to an antiderivative, the values, the difference of f at point A and B. So it's fb. This is upper limit. The value f at B minus the value f at A. fb minus fa. And remember, I introduced the theorem A last time, but we haven't gave the proof. Because it's so important, we will explain the proof. I hope you can understand it. Okay. Next, we will operate, and then we will use theorem A to calculate the many definite integrals. Okay. And first we operate. For x in we want to calculate here the left. This definite integral is equal to fb minus fa. And first, for x in the interval AB, define gx. This means we define a new function gx. The upper limit is a value x, and the lower limit is a, is a constant a. The integrand is ft. Then, by the first fundamental theorem of calculus, g prime x, this is the derivative of g is equal to, we just replace here, t by x is fx. Right? We have this. For Rx in AB, because g prime x is fx, thus g is an antiderivative of f. But here we have this function f is also an antiderivative of f. Here, but f is also an antiderivative of f. From theorem 6.3.6b, we conclude that gx and fx are both antiderivatives of f. So this means g prime x is equal to f prime x, and the functions f and g differ by a constant. Thus, for Rx in AB, we have fx is equal to gx plus c. And we have the relationship between f and g because they are all antiderivatives of f. So we can write fx is equal to gx plus c. And since the functions f and g are continuous on the closed interval AB, we have, if we write x is a, we have fa is equal to ga plus c, and fb is equal to gb plus c. Thus, fx and is equal to gx plus c on the closed interval AB. Closed interval AB. And since we calculate GA, here, GA, here, this means the upper limit x becomes A. So it's AAFT dt. If the upper limit is equal to the lower limit, then this definite integral is equal to 0. We have GA is 0. And FA from this equation, f is equal to ga plus c. So f is c. Fa is c constant. Fa is c, and here we know Fa is c. From this equation, Fb is equal to Gb plus c. So we write Fa minus Fb is equal to Fb is Gb plus c. So it's Gb plus c. This is Fb minus Fa. Here Fa is c. So minus c is equal to Gb. And now Gb is equal to Gx is the Ax of t dt. So Gb is equal to AB of t dt. And then we have Fb minus Fa is equal to AB of t dt. Right, we have this. So we operate. Do you understand? Oh, 明白了。蕾蕾说她明白了。Okay, and if you understand this second fundamental theorem, now we can use it to calculate definite integral. The second fundamental theorem of calculus is important in providing a powerful tool for evaluating definite integrals, but its deepest significance lies in the link it makes between differentiation and integration, between derivatives and integrals. This link appears in sparkling clarity when we rewrite the conclusion to the theorem with fx replaced by d prime x dx. Okay, this means if here this is g prime x, we find use the second fundamental theorem, we just find any derivative of g prime x, any antiderivative of g prime x. So we find any, we find one, this is gb minus ga. These links appears in sparkling clarity. 意思就是有很翻译。就是有很显著的，有很特别好的特征。就比较清晰的，或者是明了的，清晰明了的特征。Because this equation or this theorem is so important and it makes now this means its deepest significance lies in the link it makes between differentiation and integration, between derivatives and integrals. Because calculus is just we learn derivative and integral, and this equation links this relationship. So this is sparkling clarity, clarifying clarity. You see. Okay, and in section 3.8, we defined the indefinite integral as an antiderivative in indefinite integral. We also write we almost say the indefinite integral, and indefinite integral also an antiderivative. In section 4.2, we defined the definite goal as a limit of Riemann sum. Okay, this is the definite goal. We give the definitions of the definite goal by calculate the area between the curve and the curve between XA and axis B. So this means definite goal we give as the limit of Riemann sum. We use the same word integral in both cases, although at the time there seemed to be little in common between the two. Theorem A is fundamental because it shows how indefinite integration and definite integration are related. Before going on to examples, ask yourself why we can use the word any in the statement of the theorem. Why? Here, this one. This here we have any. Why we can use any? This FB continuous on AB. Let F be any antiderivative of F on AB. Then this definite goal is equal to FB minus FA. Why we can use the word any? You know? Anyone can explain? Does anyone? Does someone can explain any? The word any? Why? Why we use any? Any antiderivative. This means F has infinite antiderivatives. You just find one, and this result is FB minus FA. And this means if we find G is another here, G, this function is another antiderivative of F. F and G. F minus G, this is a constant C, right? Constant C. So here we use FB minus FA. This means we can also equal to write is GB minus GA. Minus GA. Right? We can also write GB minus GA. You can check. GB minus GA is also equal to FB minus FA. So we can use any antiderivative. The answer is sure. It's the same. Okay. And example 1 here is show right. This is AB K dx is equal to K times B minus A, where K is a constant. Here, we put this one. This means we should find any antiderivative over K. Any. Antiderivative over K, we find is Kx. Okay, it's Kx. This is F. This is Fx, Kx. And by the second fundamental theorem, this is equal to Fb minus Fa, right? Fb minus Fa. So Fb minus Fa is equal to Kb minus Ka. So it's equal to K times B minus A. Example 1 and questions. Example 1. Now, how about the other students? Example 1? No. Okay. And example 2. Example 2. Show right. AB fx dx is equal to b squared over 2 minus a squared over 2. Oh. So we should find any antiderivative of x. Please tell me. You find any antiderivative of x is equal to, you can choose one, is equal to, this means right, fx is equal to x squared over 2. Yes, fx is x squared over 2. And then this is this indefinite graph is equal to fb minus fa. So it's equal to b squared over 2 minus a squared over 2. Right? Yes, right. And a question, for example, 2. Maybe you can say Lily has explained for us. Okay, now example 3. This is show right if R is a rational number different from -1. Then we have this is integrand of the integrand is x, the power is R. Please tell me antiderivative of x power. You just told me 1. This is any antiderivative. Please tell me 1. X power. Yes, it's equal to by the power, right? By the power is equal to x power plus 1 over r plus 1. This means if we calculate the indefinite graph, the power, the exponent increase and over the new exponent. So it's equal to, if we find fx, then by the second fundamental theorem, this is to fb minus fa. The vx is b, this is the b r plus 1 over r plus 1. Vx is a minus this a r plus 1 over r plus 1. Example 3, 2 and 3, and questions. If no, we continue to maybe example. Oh, no. No questions, okay? If r is less than 0, we require that 0 not be in AB. Why? Can you notice one? Here, this is r is different from -1. And here, this is if r is less than 0. We require that 0 not be in AB. Why? Got it? Why? Here, r is less than 0. Maybe you can choose r is, we can choose r is -2. Okay, this is AB. We choose 1. R is -2. It's -2 dx. So we find antiderivative. This is x -2. So we find it's minus x minus 1. This is x minus 1 minus. Oh, right. This is fx. This is fx. So, all right here, this is fx. So it's equal to here. We write 0 not being AB. You can know 0 not being AB. Why? Why? Because here, the integrand, this is x power is -2. If 0 in AB, if 0 in AB, this fraction is unbounded on the interval AB, right? It's unbounded. So it's not integrable. We find if fx is continuous, then it's integrable. This is unbounded. So this is improper indefinite integral. It's not. We will learn it later. Okay. So this is the y with clear right. 0 not being AB. Now it's convenient to introduce a special symbol for FB minus FA. We write FB minus FA is equal to FX. Here FX write like this. FX. Here, this is A, B, right like this. AB, this means FB minus FA. With this notation, we write this is x squared. Lower limit is 2, upper limit is 5. We find any antiderivative is x cubed over 3. Just write x cubed over 3 to 5 is equal to 125 over 3 minus 8 over 3 is 39. Example 5. Example 5, I hope you can do it by yourself. Quickly, maybe give you 2 minutes.
老师你好，是我于
你好
连，我的手机有问题，你没有做我的名字，你没有叫我的名字，
What's your name?
于连，
You are late for a long time.
老
I call your
师
name.
我的手机有问题，
What's wrong with your phone?
I don't know， 老师，我不知道，现在可
When I
以，
call you, what are you doing?
老师 I'm trying to tell, I try to explain to you my phone is not good, so I'm trying to download the app, but now it's working, 老师。
Maybe I only give you this chance, okay? Only one chance. Next time, I don't listen, and maybe I want to change it, okay?
好，谢谢啊。
Because I see your attendance. I think your attendance is about your absent is about 1 over 3 hours.
Yeah, 老师 already know it.
So it's very dangerous. Okay,
Please,
next time.
Please,
Next time,
thank
remember, I won't change it, okay?
谢谢。
Exam 5. Quickly, if you have finished, you can send to your answer to our chat, to our meeting here. And I will check it quickly. Exam 5. Yeah, I see Lily's answer. Yeah, right. Wow. Okay, how about the other students? I'm also expect to receive the answer. 期待你们的答案。It's you say it's familiar 类似的答案。Yeah, but I also want to see it. Right? I want to, but I'm still looking forward to the answer. Although it's the same, it's okay. I just want to see yours. Okay, let's see Fashimus. Let's say the x over 3 plus x over 3. Here, the definite we can find antiderivative. This x 1 over 3 plus 1 over 1 over 3 plus 1. 8, 1, 8, 1. So we calculate this one. I think this is right. And the question is breakdown 5. If no, we continue to next. Explain next. Next. And the question is for exam 3, exam 5. No? Okay, we'll continue. Okay. And then using the second fundamental theorem of calculus. The way to use the second fundamental theorem of calculus is to evaluate a definite graph such as is to first, we should find an antiderivative fx of the integrand fx. Substitute the limits and compute fb minus fa. This all hangs on being able to find an antiderivative. It's for this reason that we return briefly to the evaluation of indefinite growth. This means if we want to calculate the definite growth, then I think you must be familiar with indefinite growth. Otherwise, it's hard for you to calculate this. Okay. Now, here, then we use the in the indefinite growth lecture, maybe lecture 3 or lecture 4, we will calculate the indefinite growth. We use the method of substitution. And today, for a definite growth, we still have the method of substitution. This means in section 3.8, we introduce the method of substitution for the power law. This law can be extended to a more general case as the following theorem shows. And I forgot to pronounce this word. I don't know. Later, we'll say that the substitution law is nothing more than the chain law in reverse. We have theorem B. The substitution law for indefinite growth. Let G be a differentiable function, and suppose that f is an antiderivative of f, and then we have this is f g x g prime x is equal to fgx plus c. fgx plus c. And remember, we have learned it before, right? In section 3.8, we have learned the substitution for indefinite growth. Here, we just review it. Okay, if we want to operate, this means all we need to do to operate this result is to show right the derivative of the right side is equal to the integrand of the integral on the left. This is a simple application of the chain rule. We just calculate this derivative here. This one. This is a simple application of the chain rule. This is the dx fgx plus c. And by the chain rule is f prime x gx times g prime x. F prime gx is equal because f is an antiderivative of f. So we write this is f gx g prime x. And then we operate. Okay, we normally apply theorem B as follows. In an integral such as this one, we write u is gx. Here we have this is f gx and g prime x. We write u is gx, and so write du over dx is equal to g prime x, right? From this we have du. This is du is g prime x dx. G prime x dx. The integral then becomes, yeah, this is because u is gx, so it's fu. This is g prime x dx replaced by du, so it's fu du. Because this one f is an antiderivative of f, so this is fu plus c, and then we replace u by gx, so it's fgx plus c. Thus, if we can find an antiderivative for f, we can evaluate this complicated indefinite integral. The trick to applying the method of substitution is to choose the right substitution to make. In some cases, this substitution is obvious. In other cases, it's not so obvious. Proficiency in applying the method of substitution is just comes from practice. Okay, exam 3. Exam 7. Now we can do example 7 together, and I will leave exam 9 for you. Here, this is sin 3x. Which one? This one, here, this is sin 3x. If we calculate this indefinite integral, maybe you can think of this one. Sin x dx. That is, they are different. Sin x dx, we know this is equal to, please tell me this result is equal to this one. Hello, sin x dx. This is equal to, this indefinite integral is equal to it's minus cos x plus c. Don't forget to plus c. This is absolute constant. Yes, minus cos x plus c. Okay, which the number is one. It's minus cos x plus c. Minus x plus c. Oh. That's it. Right. And so here we have the obvious substitution is we let u is 3x. And so right, we can find the du, the differential of u. is 3 dx. And the last sin 3x dx is equal to, we just write like this. It's equal to u is 3x. So sin 3x is sin u. And du is equal to 3 dx. du. So dx, this means dx is 1 over 3 du. Right here. 1 over 3 du. And 1 over 3 we write in the front of this indefinite integral times this sin u du. And sin u du is minus cosine u plus c. This is 1 over 3. It's 1 over 3 because c is absolute constant. So we just write this is c. So, and then the last step, which is replace u by 3x. So it's minus 1 over 3 cosine 3x plus c. And notice how we had to multiply by 1 over 3 times 3 in order to have the expression 3 dx is equal to du in the integral. And we can also just replace by the substitution, replace u by 3x. du right is 3 dx. Okay, this one. And example 7. And questions for example 7. No, maybe example 9. Try to do by yourself. Do it by yourself. Example 9. Quickly. As I think it's very easy for you. So give you only 2 minutes. Okay? Only 2 minutes. Is x cubed, the square root of x4 plus 11 dx. Anyone? Oh, always Fashimu and Lily. Why? Why other students to listen to your answer? Suppose x power 4 plus 11 is z. For x cubed dx is dz. This means x cubed dx is 1 over 4 dz. Right. This is equal to 1 over 4 square root of z dz. It's 1 over 4. Z is 3 over 2 over 3 over 2 plus z. Oh, right. Yes. Okay, right. By Simon, I say the answer is right. Oh, I say Lily's answer. The appropriate substitution is u is x power 4 plus 11. Let's see. Right. 106. X 4 plus 11, 3 over 2 plus 6. Right. Here, right? We see the right answer. Mentally substitute u is x 4 plus 11. And if you are familiar with this substitution, maybe you can omit some steps and you can directly write this is equal to is x 4 plus 11. Here is power 1 over 2. Here, you just times 4 divided by 4 is 4x cubed dx. And you can directly get, you can write like this. This is x cubed. You directly, you can think of this x cubed dx is equal to d, this is x, this is power 4, and divided by 4. Divided by 4. And then you can write, this is another method. Okay, you can you can grasp 1 and write is x4 plus 11. Here is d, this 1 over 4 right here. This is a constant 1 over 4. This is d x4. x4 dx4 is also equal to dx4 plus 11. So write like this. And then, because my mind, maybe I substitute x4 plus 11 is u. So this is the square root of u du. Oh, you can directly write this 1 over 4. This is equal to this u 2. So this is 2 over 3. 3 times this is x 4 plus 11. Plus 11. Plus 11. This is a 3 over 2. Plus 6. Okay, plus 6. I also write like this. Okay, we continue. Here. Example 10. Therefore, evaluate this x squared plus x. The square root this is 2x plus 1. Quickly, example 10. Please remember, this is a definite integer, okay? This is not an indefinite integer. This is definite. We have lower limit is 0 and upper limit is 4. We give you 3 minutes. This is not. Yes. Okay, I see Lily's answer. Wow. That u is x squared plus x, and du is 2x plus 1 dx. And first, she calculates the indefinite integer is equal to is equal to u. This is the power is 1 over 2. 2 over 3, u 3 over 2 plus c. Right, and then use the second fundamental theorem. It's 2 over 3. Let's see. 2 over 3. This is x squared plus x. Power is 3 over 2 plus c. Leila, you just choose one antiderivative. This means when you calculate the definite integral here, you can omit c. Okay? You can omit c. You just write 2 over 3 x squared plus x. Power 3 over 2. 0, 4. And you can omit c. Vx is 4. Calculate. Vx 0 is 0. So the final result is 60. Right. Here, this is our answer. Let u is x squared plus x. We find that du is equal to 2x plus 1 dx. Let's say Hashimoto's. Hashimoto's. This is x cubed. X cubed. Here, this one is x squared plus x is to z, and 2x plus 1 dx is dz. A square root of z dz, right? Okay, I see. Maybe it's different from. Oh, right. It's a little different from Lily's, and we'll share Fatimo's because Lily's is a weighted girl. It's a weighted girl. So this one. Here, so this one. His suppose and suppose x squared plus x is z. And we have 2x plus 1 dx is equal to dz. And this is from 0 to 4. Here, this is the square root of z. And 2x plus 1 dx, we write this is dz. Here, this is dz. We have this is 2 over 3. Z 3 over 2. This is 1, this is 4. And so, this is 2 over 3. 4, 0. X is 4 square plus 4. This is 0 square plus 0. Okay? The final answer is what? It's different from, let's see. Yes, it's about 60. 59.63. It's right. Okay. Here, note that the state of the indefinite integration cancels out. Always, as it always will in the definite integration. That's why in the statement of the second fundamental theorem, we can use the phrase any antiderivative. Alright, let's say because C of the note that C of the indefinite integration cancels out, as it always will in the indefinite integration. So we can use any antiderivative. In particular, we may always choose C0 in applying the second fundamental theorem. Okay, we always choose C0 because C can be cancelled out. Cancels out. Okay. Example 11, quickly. I think you should do it first and then I explain it. Remember, we have 33. I think we have 31 students. We should have 31 students, but here in our meeting, only 28 students. Let's check it. We have check it. One, 2, 3, 4, 5, 6, 7，40个人，5个，50个，30。There should be 30 students here in our meeting, but why only 27? Only 27 students. This means some students already skipped. This is skip 逃学丢掉了。Skip our classes. Quickly. Here is 0 power 4. This is sin cube 2x cosine 2x dx. Which one says 1 alright? Your 202. Here is our answer. Let's u inside sin 2x. Alright? Oh, I'm waiting for you. Waiting for your answer. Or I explain here. We let u is sin 2x. So we have du is 2 cosine 2x dx. And the last here is we first calculate the indefinite integral. This is sin cube 2x. Right here is u cube. And this cosine 2x. This cosine 2x dx. Right is 1 over 2 du. So it's 1 over 2 du. U cube. We find it's 1 over 2 u 4 over 4 plus c. So it's sin 4 2x. Alright, plus c. Therefore, by the second fundamental theorem of calculus, we have is equal to 1 over 8 minus 0. So it's 1 over 8. Example 11. Any questions? No? Yeah, okay. Let's see Fashima's answer. No? Yes, 1 over 8. 1 over 8. 1 over 8, 0. Oh, right. Yes, you're right. Let's see Fashima's answer. This is a little different from here. From example, the PowerPoint, the answer in our PowerPoint, because Fashima, I know, I remember he has learned it before, so he used this is the substitution in the indefinite integral here. He likes SUPPO SE. Suppose let Z is sin 2x. So this 2 cosine 2x dx is dz. This means dz over 2 is equal to cosine 2x dx. And here, 11, we know the upper limit is pi over 4. Here, the lower limit is 0. And if we write z is sin 2x, we can change the upper and the lower limit at the same time. This means here this is x is 0. Here right, this is x is 0 here. X is 0. We know z is sin 2x. So from this equation, we get Vx is 0, z is sin 0. So it's 0. And here upper limit, this means x is power 4. Vx is power 4. From this equation, replace power x by power 4. Z is sin pi over 2. So sin power 2 is 1. This means we have changed the upper and the lower limits. So it's equal to, this is sin cube. So it's z cube. It's cosine 2x dx. So it's dz over 2. So it's 1 over 2 z cube dz. And we find an antiderivative is 1 over 8 z power 4. Here, the lower limit is 0. Upper limit is 1. It's 0, 1. So first we when this 1, the value is 1. With this 0, this is 0. So the final answer is 1 over 8. We use another method. Okay, we will learn it later. I hope you maybe understand this. Yes. Okay, continue. Here, this is just the way we learned it. Theorem C. This is a substitution rule for definite integrals. And we know we learned the substitution rule for the indefinite integral. And here we can learn substitution rule for definite integrals. We let g have a continuous derivative on AB, and let f be continuous on the range of g. And then we have this AB, fx, fgx, g prime x dx. So here we let u is gx. U is gx. Let u is gx. And the lower limit, this means x is a. We find u is ga. So here, u is ga. And vx is b. We know u is gb. So here, upper limit is gb. And fgx, this is fu. And g prime x dx, you know, du is equal to du. Du is equal to g prime x dx. So we have this equation. And if we want to operate, we will imagine f be an antiderivative of f, the existence of f, guaranteed by theorem 4.38. And then by the second fundamental theorem of calculus, we have this f u d u g a g b. Right. Is equal to, because f is any antiderivative, so this should be fu gb ga. The second fundamental theorem is equal to fgb minus fga. On the other hand, by the substitution rule for indefinite integrals, we have this means we have calculated the right side is equal to fgb minus fga, and we see the left side. First, we consider the indefinite integrals. This one, you know, this one we use the substitution rule for indefinite integrals. Because f be any antiderivative of f. So if I'm this f gx plus c. And so again, by the second fundamental theorem of calculus, this means we have found antiderivative of this integrand is f gx. So that by the second fundamental theorem of calculus is equal to f gx. This is a b. So it's equal to FGB minus FGA. Minus FGA. So this means we operate. Okay, maybe we'll have a break. Okay, have a break. Hello. Hi. Hello. Hello. Okay. Because I think only me. I was worried about. I'm a little worried about it because I think only I think maybe 3 students respond to me, and I think I was talking to myself. Okay, exam 12. We use substitution through. Yeah. Okay. And exam 12. Here is we use the substitution through for definite integral. Here this is x plus. Yeah. OK， 余化。哦，余连。Here this x plus 1. This is x squared plus 2x plus 6. Square. Denominator is x plus 1. So we can write. Here is x squared plus 2x plus 6, and this is x plus 1. So of course, it's obvious that we write u is x squared. X squared plus 2x plus 6. Okay, and from this we find du is equal to 2x plus 2 dx. And we will change the lower limit and the upper limit. Okay, at the same time, this is A, this is B. By the substitution though, so which is right, this is GA, this is GB. So here, this means the lower limit, this is x0. We write x right here. Right here, this is x0. And because u is x squared plus 2x plus 6, we have u is vx is 0, u is 6, right? U is 6. And vx is 1. Vx is 1, u is equal to x is 1, u is equal to 1 squared plus 2 plus 6. So it's equal to 9. And then we write this indefinite integral is equal, which is the lower and the upper limits at the same time. This is 6, from 6 to 9. And here x plus 1. The denominator, this is u square, right? U square. And x plus 1 dx. X plus 1 dx. We write this is equal to 2 du over 2. So it's 1. It's du over 2. It's 1 over 2 du. So we write is equal to 1 over 2. This is 6, 9. This is u. This is power minus 2 du. And this is 1 over 2 times minus 1. Oh. U minus 1. The 6, 9 is equal to minus 1 over 2. This is 9 minus 1 minus 6 minus 1. Let me check it. Right? Let's see Fatima's answer. Let's see if we are right. Yes, right. Minus, we are saying minus 1 to 1 over 9 minus 1 over 6. So it's 1 over 36. This is the right answer. 1 over 36. Hello? And questions for example 12. Any questions? Any questions for example 12? No questions? Oh, let's see Lily's answer. U is x squared plus 2x plus 6. U is this one. U is 6, V x 0. U is 9, V x is 1. Here we write is 1 over 2u minus 2 du. So we write is 1 over 36. Right. Okay. If no questions, continue. 33. Let's do it by yourself. 3. Exam 3. Maybe give you 5 minutes. Okay, 5 minutes to finish exam 3. Five minutes. Okay, I received Lily's answer. U is square root of x. Let's check Lily's answer. U is the square root of x. Du is 1 over 2 square root of x. X is pi over 2. Oh, Lily, I hope you write U and X clearly because I will say they are almost the same. Right, U and X. You can say you write X and U almost the same. U is pi over 2, Vx is pi square over 4, right? And X is pi square over 3, U is pi over 3, right? So it's equal to, this is equal to cosine U. Cosine U. Du is equal to, so 1 over is 2 du. Sorry, right, so it's 2 du. This is 2 sine U, pi over 2, pi over 3. When U is pi over 2 is 1, right? When U is pi over 3 is the square root of 3 over 2. So it's 2 minus 3, the square root of 3. Yeah. Okay, let's see fractions. Okay, 5 minutes. 2 minus 3. Hello. Can you say fractions answer? Okay. Maybe write suppose SUPPOSE, right? You omit E. SUPPOSE. Let the square root of x is z. So dx, dz is equal to 1 over 2 square root of x dx. Right, SUPPOSE. And again, 2dz is equal to 1 over square root of x dx. This means here, this part can be replaced by 2dz. This means this part dx, 2dz. And is equal to the 2dz. This is the cosine z. Here, this part is cosine z. This is the cosine z. Oh, cosine z. Cosine z. And here he write x upper limit is pi square over 4. So z is equal to pi over 2. Here x is pi square over 9. He had z is pi over 3. And the second fundamental theorem is 2, this is Sunday, pi over 2, this is pi over 3. Here is equal to 2 times sine 90 is pi over 2 minus sine pi over 3 is equal to 1 over square root of 3 over 2. So it's equal to 2 minus the square root of 3. Right. Maybe this is A plus. Great. Okay. And the questions for this one? No. Okay. Okay, maybe you can have a break and our class is over. Okay? I hope you can understand all this we learned. We have learned. Okay, because I only received maybe I think my students haven't sent your homework to my mail. Please quickly send your homework to my mail. Okay, maybe you can say bye bye. And tomorrow we will learn the area of a plane with x-axis and y-axis related. Yeah, my mail. I have two. Okay, you use this one. Send to this one. Just this one. Okay. Okay. Bye bye.